Okay, the last presentation for this set of four is from St. Catherine University. Okay.
No, you could have.
Step back or just make sure this is looking at the answer. Forgot to share the slides in my previous time.
All right. Check 1, 2, check 1, 2. Good, all right. So you will notice in the booklet, so it's sort of a caveat first. So I am not Anissa Tapper or Hope Halsey, or Caitlin Blair, or Zoe Sternberg. So that is our 2023 graduates. So 3 of the 4 individuals are at different various locations of graduate school shopping at this point. It told me that they would not be here for those reasons. So and then one student had a family emergency that I found out about 24 hours ago. So I am taking over sort of for the presentation today. So obviously I'm not those individuals. So I am faculty. So I am going to use their presentation and give you this talk here. So this is, I'm going to hit pause.
I always forget how to fix that setting, but yeah, your note page is showing up on
This
the.
is what's saying in Zoom. This thing.
Oh,
Doesn't really. Go ahead.
okay. So this is title for our talk is stratospheric neutron detection during the 2023 and 2024 solar eclipses. And again, I'm giving this on behalf of the 2023 graduates. So we're going to be going over kind of some background with eclipses, some of our goals. We're going to some of our methods. We'll talk about the analysis of how we're planning on looking at our data, and then future plans, and then I will do a little bit of a summary. So that's kind of how we're planning on covering things. So this is a total solar eclipse from 1999. As far as it looks like. So our research question for our group is: do neutral particle counts in the stratosphere vary under the effect of solar eclipses? So that's the premise of what we're planning on looking at. So how do those things change? And so in order to sort of address that question, trying to think about sort of how we would address this is sort of what is a sort of what's interesting about 2023 and 2024. So there are going to be two different eclipses. So 2023 is October 14th will be an annular eclipse and 90+% coverage in that particular instance. So not a complete totality, not a complete blockage of the sun in 2023. And then in 2024, that is a complete blockage of the sun in that instance, and you will see what's known as the ring of fire in that particular instance. So you'll start to see the corona of the sun. So this is animations of where the eclipses will be traversing the Earth in that particular instance. So this is also some pictures taken before from eclipses, and so the top is showing you what an annular eclipse would appear as. So again, not complete blockage of the sun, and then the bottom being a total solar eclipse. So 2023 will appear more like what you see in the top, and 2024 will be appear more what you see in the bottom of that particular instance. So what are we going to be looking at during these eclipses? So we're going to be looking at neutrons. So we're going to be looking at something called the Regner-Pfotzer maximum, or the RP max, as I will refer to it as. This occurs between 15 to 25 kilometers. And we're going to be looking at galactic cosmic ray showers, or GCRs. So it turns out that sun sends out all kinds of material. So protons primarily are the things we're interested in, colliding with atmospheric particles, and that collision then generates a set of showers that generate the electromagnetic, hadronic, and mesonic components. And we're looking at those charged particles using Geiger-Müller tubes, or GM tubes. And so it turns out that if you plot this out and look at this over a long period of time, there is a maximum where you'll see these showers occurring, and those are primarily due to your charged particles. And that maximum again occurs between 15 to 25 kilometers. So that's the charged portion. You might say, well, neutrons are not charged. Yes, that's correct. But so with a Geiger-Müller tube, we also pair that with a personal neutron dosimeter, or a PND. And so that PND measures neutrons. They're used oftentimes in facilities that's where you want to be knowing what your exposure is for neutron exposure. So like nuclear facilities and such, so power plants and such. And so we fly those, and the cool thing about those personal neutron dosimeters is they measure the dose very effectively, and so we can actually calculate the dosage delivered on our payloads when we fly those. So here is sort of the process. So for the chemists in the room, I'm not going to attempt to do that. I play a chemist on TV, but not one here. But this is sort of the process. So if you understand, so you have a tube that basically has some material in it, and when the neutron runs into it, it runs into this material and then generates this bubble. And so the bubble then shows up in the dosimeter, and that tells you, hey, we ran into a neutron in this particular instance. So it's actually a pretty neat little process, and this can be recorded on a camera that's inside of the payload. And kind of a preview of things to come. So I was thinking that probably our graduates were going to be sort of coordinating with our show and tell experiments that's happening in over the lunch period. So Abby's going to be showing you our payload over that piece. So there, and so you'll get a chance to talk to her, and you'll actually get a chance to see this payload. So she'll explain more if you're like, all right, let me see some of these things in action. She'll be able to do that. So also kind of showing some clips parameters. So this is kind of letting folks know. So we're going to be in 2 different locations. So this is also later in the slides as well too. But we're going to be in New Mexico School of Mines is going to host us in 2023. And then we're going to be at Taylor University in 2024 in that particular instance. And so the annular eclipse lasts significantly longer, 4 minutes and 26 seconds, actually a fairly long period of time. And then the totality eclipse is 3 minutes, exactly, I guess 3 minutes, right, in Upland, Indiana, where we're going to be stationed for observing this. And so having been at the 2017 eclipse myself, so I'm putting my own personal spin on this since I'm taking over now. That one was well under 2 minutes in that particular instance. So to get an additional minute worth of time of totality is going to seem very, very nice. So it's a very wonderful experience to be part of that. So, and this also gives you some other details as far as what we're going to be seeing. So 100% coverage in 2024, it's a full total eclipse. And at Coastal Lunas, it's almost 90%. So here is the methods as far as what things look like. So again, we're using weather balloons to send these things up. So this is our neutron payload. So this is the one that's actually there. And so inside this, again, you get a chance to talk to Abby a little bit later about these things. So we have things like an Arduino that's logging the data from our Geiger-Müller tube. So this is our RM60 that's doing that for us. We have a GoPro camera. We're in the process of looking to upgrade our GoPros. We're still using Hero 3s, so we need to upgrade to something better than that because our battery life is going. And we want to try something a little different anyway. So that's going to be part of what we're looking at this summer is upgrading our camera. And why do we need the camera? So we're looking at the personal neutron dosimeters. So these are actually what these devices look like when they're new. So they are a clear, they have a clear polymer in them. It's looking for those neutrons. And then we place them on a gridded background such that when we look at the GoPro video, we can say, all right, this is quadrant 1, 2, 3, 4, 5. We see a bubble in quadrant 1. It just makes for easier data analysis. We start to look at the GoPro footage in that particular instance. What we then have to do, so this is the fun part of the analysis. So yes, this is what we start to do in this instance. So you might say there's probably easier ways of sort of doing this, using sort of AI to sort of do this type of things. What we choose to do is sort of very old fashioned. So we run the GoPro, we look at the footage, and then we basically say, all right, here's bubble, and this occurred at 10:37 on GoPro file 7. So that's when we sort of go through that step by step. And then we correlate the GoPro time with the actual time. So, and you might ask, how do we do that? Very, very low tech. When we let go of the payload, we go, launch. And that shows up in the GoPro footage pretty well. And then we can, and in fact, I have no doubt that if they probably were here, the 2023 graduates would have a funny video of me from Iowa State with Eric going crazy on that, because I launched about 4 or 5 times to make sure it was, we knew that we were launching. So, but it does work pretty well. And we will have, there's a QR code that's going to be part of our afternoon show and tell experience. And so you can actually scan that on your phone, you can see actually what things look like as far as the detection of these bubbles. So it's a really cool QR code that shows what a single bubble detection looks like. 2, 3. So we do actually look for coincidences. And the two tubes that are close to each other. So one of the things that we also do is that we can also do coincidences. So we can actually take a look at bubbles that are occurring in this one and this one simultaneously, at least as far as we can tell in terms of the video. And that tells us something about that there might be a particle that's going through both of those. And so it's showing you a particle track. So it's really, really cool. These things can do actually a fair amount. And so one of the things that we'll talk about a little bit more is that we're changing our orientation. So not the steel, but she's going to let you know about some of the changes that we're going to payload.
One more minute.
Okay, and then this is what this RP max looks like. So this is the counts here. Here's the bubbles that occur. So these are ones that have coincidences. So we're starting to look at that. So here you see the red lines, that's the RP region. So where you'd expect to sort of see more particle counts. So that's what when you start to overplot the neutrals and the charged. Future plans, we're going to be New Mexico School of Mines and Technology in Socorro and Taylor University in Upland. So those are going to be our 2 launch locations. And then some future plans that would be remiss. So we're also part of the National Eclipse Ballooning Project, NABP. We're going to be taking a look at gravity waves in the atmosphere. So we're partnering with St. Cloud State University and Fond du Lac Tribal and Community College. So they are partnering with us, and we're going to have a team looking at temperature variations as the eclipses go by in both 2023 and 2024. So, and just sort of summarizing what we're doing. So we do have our own contact page there, and thank you for your time.
We'll take some questions. Go ahead and repeat the question before answering.
Yeah,
I'm gonna start, and that is, are you going to fly more than just 2 of these things? Eclipses don't come around every. Why don't you fly a bank of 12 or something like that?
So what we're planning on doing is
Did you repeat the question?
oh yes, you remind me. All right, so the question was eclipses don't come around very often. Would it be useful to have multiple different balloons sort of flying during the eclipse to get as much data as possible?
Or even 12 in one payload.
Or 12 in one payload. And so what we will do is we're limited as far as weights restrictions. So there is a 12-pound, it's known as the goose limit by FAR 101, which is the flight regulations. And so we could have 2 of these payloads. So actually our plan is to have 2 of these payloads. So we'll be able to fly 2 of these, and we'll have 2 neutron tubes in one and 2 in the other, plus the GM tubes. That's as much as we can get on one stack. We are planning on flying 2 balloons in that instance, and much more than that gets to be, we have to recover these things because unlike some groups, we don't telemetry our data down. We actually have to recover these things. And so if we have hard recovery, going to get 2 stacks is going to be enough for, depending on if we get 2 free recoveries, that gets to be a bit interesting. So hopefully we don't, but we're planning on just doing 2. So we'd love to do more, but there's also tracking related to that. And we've got funds to sort of do this much and do it well, and that's what we're going to do. So we flew 3 in the last eclipse. We're going to do 2 this time, just because we have to do this other project as well too with the radio sondes.
One more question, and then you can ask.
Yeah, and Abby would love to get some questions too. Over
Just curious about the length of time it takes for a bubble to form. Is that like 1 frame in terms of your movie? And then you're talking about coincidences. Just curious about that.
That's really cool. So the QR code is repeat the question. So the question again is how long does it take for a bubble to form in terms of, do you see, does it occur immediately or does it take a little while? Turns out that these bubbles actually do take you can see them almost immediately. They do produce a sound. So that's usually how we write things up on the board, is that we hear audio and also a bubble. So that's really cool. But the interesting thing about this polymer is that sometimes the bubble will form, but you see over time it starts to expand. It's almost like the polymer I don't understand the chemistry as well. The company doesn't tell you what it is exactly made up of, other than I think there is some Freon 12 that's in there as well too. But the bubble slightly expands over time, just after it's been created. So, but I would definitely suggest Abby can show you the QR code. It's really interesting to see sort of how these things show up and what they appear as. So yeah, I would definitely encourage you to take a look at that. So she should show you that QR.
Okay, thanks again, Eric.
Thank you.
What does it mean? To see if the content